Every line, every diff, every function the AI writes, you're checking it, right? Well, stop. Stop reading the code. All right, let's talk about who's even reading diffs right now. The people reading every line? Senior devs, staff engineers, people who've been doing this for years. And if you're a senior dev still reading every diff, stay with me here. You might not even be aware of this, but there's a good chance you're not doing it because you're worried about correctness. You're doing this because this is the work that defines you. You spent years building this skill to look at every line and all of the code and know if it's just right. That skill was valuable, incredibly difficult to build. It really mattered. But the role is changing. Here's what I've watched happen. A year ago, you definitely needed to read all the diffs. 6 months ago, you still needed to verify the code was in shape. 3 or 4 months ago, you were best off spot checking, but still making sure that it was on the rails, because it could really kind of wander. Even today, it will wander from architectural principles from time to time, especially as context lengthens. I'm not pretending that it's solved, but look at the trajectory. Look at the curve. A year ago, read everything. Now, spot check. Soon, why are you reading at all? The question really isn't whether you should stop reading the code. The question is when. And the answer is sooner than you think. Here's the whole thing. Let's imagine that you aren't reading the code reflexively. It's not just because it's some self-definition type of thing. Can you name what you're worried about when you read the code? If yes, write a test. Like, for example, let's say you don't want it writing for loops a certain way. Well, write an evaluator. Have it run in CI, done, easy. It actually checks forever. If no, if you can't name it, you don't have a concern. You have anxiety. And reading won't fix that. You're trying to feel better, not solve a problem. Think about it. If you're reading the code because you're worried about something specific, you're worried it's going to write inefficient queries, or it's going to duplicate code, or it's going to break the authentication flow or something big like that, then you can name that. And if you can name it, you can test for it. But if you're reading the code and you can't articulate what you're looking for, you're not checking for problems. You're checking for comfort. You're trying to maintain a sense of agency over something that's moving faster than you can track. That's not engineering. That's anxiety management. Now, I can already hear it. Not everything can be tested. And you're right. Not everything is a unit test. But almost everything is checkable. Let's say you're looking for duplication and worried about that. There are tools for this. File size, well, set a threshold. Bundle size, it's measurable. Track it. It fails if it bloats. Architectural drift, dependency rules. This module can't import from that module. Tools exist for this stuff. The point isn't that you never look at anything. The point is, for the stuff you care about, build a check. Define the rule. Let the system enforce it. Let me show you what this actually looks like. I'm working on an app. Let's say that the nav bar here needs to collapse more properly on mobile. So I'll take a quick screenshot, maybe even mark up the screenshot, and then I'll give the screenshot to Claude and say, help me degrade the header bar correctly for mobile. I kind of want a more responsive experience. So here we are, it made the change. Everything lines up much better in a mobile way. And if we look through the changes, we can start looking through the diffs, and maybe 50, 100 lines or so of change that it went through to do all of this. I could go through and verify every bit of this to make sure that it did each one of these right. So not bad, but here's the problem. That would take me going in and doing that work. If I want hundreds of changes in a day, and of course I do, I can't do that for every single one. I'm the bottleneck. But frankly, there's a bigger problem. Let's say I do eyeball this in time, and I verify it looks right before we ship. Great. Then next week, another change comes in, something unrelated, let's say, and it quietly breaks this mobile layout. Some CSS gets shifted like it does. Will I remember to come check this one thing? Will the next person? Obviously not. So from a software engineering standpoint, what I actually want to protect is the intent. If my intent is that these things don't overlap and that it looks good on mobile, then that's what I need to test for. So instead of reading the code, I can say, write a visual playwright test to kind of test and verify that the navbar header and other changes that we've made here don't revert. We want to make sure that they don't overlap, and on mobile, they look nice and clean like we have here. Okay, and I know this isn't new to anyone, but that's it. One test, it checks forever. I never looked at the implementation this way, and that's the trade-off. 2 minutes to write the test versus 2 minutes to review the code, except the test keeps working tomorrow and next month, and when someone else makes the changes at 2 a.m. This is definitely the way to go. And for the stuff that truly can't be automated, specific domain risks, edge cases you've seen before, that's what targeted review is for. Spot check the specific concerns, even arm your CI for warnings when these areas change. That's not read every line of every diff. One is precision, the other is a bottleneck. So let me ask you something. Why did we ever care about code quality in the first place? It wasn't because clean code is morally superior. It wasn't because elegance is its own reward. It was because we needed to maintain it. As architecture wanders, it introduces complexity, breakage, non-predictability, inefficiencies. If there's no explicit structure, if everyone is coding in a Wild West style, things become debilitatingly difficult. We know this. That was the real cost, the reason we invested in clean code and separation of concerns and abstractions. All of it was about reducing the future cost of change, making the system maintainable by humans who had to read it, understand it, validate it, and future modify it. But here's the thing. That part of the problem is solved. If your intention is to build code that's maintained by agents, and look, this shouldn't be an if, but if that's what your intention is, then it's no longer your concern about how maintainable the code is by human standards. These agents write very maintainable code, and even when they don't, they can refactor it immediately. You can give them that task at any time. Just restructure this for maintainability, and they'll do it, always. The maintainability that was a massive cost in the past is now an infinitesimally smaller cost, because agents can maintain what agents build. You're solving a problem that doesn't exist anymore. Okay, so here's a thought experiment. When was the last time you asked if the wire harness inside of your car was elegant? All the wires that make everything run? You have requirements for how your car should work. Your expectations, guardrails is what we would call them. It should start, the brakes should work, it should meet safety standards. But the wiring inside, the rat's nest of cables behind the dashboard, you don't care. You don't ask about it, you don't inspect it. You care that the car works, that it meets the spec, that the outputs match your requirements. That's where we're headed with code. Outputs over internals. If the outputs are correct and the inputs are correct, and you can measure everything else that you care about, then what's in the middle doesn't matter, even if it's magic, or even if it's a mess. Would you reject a car that runs perfectly because the wiring isn't pretty? And here's the thing you can't escape. If you still believe that you should be reading the diffs, you have to read every line every agent ever produces, and it has to be you reading it. You've inserted yourself as a single point of validation for everything. That's a single point of failure. You've become the bottleneck for throughput. And unless you can name what you're catching that a check couldn't catch, you're just slowing everything down for comfort. Think about scale. One project, maybe you can keep up. 2 projects with agents working in parallel? 3? 10? This doesn't scale. Reading every line is the most brittle system you can design. You're setting up a failure scenario and calling it diligence. Look, I'm not saying today, right now, in every system, you never look at anything. Some systems aren't there yet. Some mission-critical paths deserve an eyeball. Some edge cases are worth a glance. I still believe maybe 20% of what's happening warrants some attention. But the trajectory is clear, and if you're reading every line because that's what good engineers do, you're applying yesterday's best practice to today's reality. Here's the practical version. Understand the shape of what's happening. Verify the architecture is being followed. Spot check things that are mission critical or have characteristics that models might struggle with. That works. But read every line of every diff? That's not diligence, that's denial. The goal is self-checking systems, CI/CD that validates what matters, guardrails that catch what you care about. And once you have that, your job isn't verifying code, it's defining what correct means. Okay, I want to say something directly to the senior engineers watching this and staff. I know what reading code meant to you. I know what it felt like to look at a PR and kind of immediately be able to see the flaws, to suggest the better pattern, to guide junior engineers perhaps, maybe to better or more exciting solutions. That skill was real and it really did matter. It created value and really relationships. But some of that value is about maintainability. And that's the agent's problem now. And some of it was about power, about being the person who could say, this is good enough, and defining yourself as the arbiter of quality. You have to be careful about that. I'm not attacking anyone, but if you're reading every diff an AI produces, looking for things to criticize, ask yourself why. Is it because you genuinely believe that you're catching problems that tests couldn't catch? Or is it because you're trying to preserve a role that's disappearing? The craft is changing. The skill that made you senior, reading code, understanding systems, knowing the right pattern, that skill still matters. But it's applied differently now. The art is now in the specification. What does correct look like? What are the guardrails that would help here? What matters enough to test for? That's where your expertise goes. For some people, the process is the art. The craft of clean code, the elegance of well-structured systems. I get that. But the craft is changing. The art isn't in writing beautiful code anymore. It's in defining what matters in building a system that verifies itself, in knowing what to measure and what to let go. Stop reading the code. Start defining what correct means and test for it. I think it's really important that we're honest about the changes that we're seeing. Our skills are still needed. Like fundamentally, they will be for a long time at the very least. Don't worry about that. Don't preserve that aspect of it. That's a losing battle. That battlefield is not even out there any longer. It's gone. So it's time for you to look forward. Figure out a way to make the system easier to manage, to maintain itself and test itself. Then you'll really be putting all of the skills that you've learned over the years to really good use that other people literally cannot do. All right. Sorry for the tough love here. Thanks for coming along for the ride on this one, and I'll see you in the next one.